Okay, so the next thing we'll learn is electric charges. So now I've got two balls. Okay, so one is negatively charged, one is positively charged. So what will happen is that they will attract each other, right? This one you should know. So when they attract each other, it's like unlike charges attract lah. So like charges repel. So one more thing you have to know is that if this is a charged metal sphere, and you have an uncharged metal sphere, what will happen is that this charged metal sphere would attract your positive charges to this side and your negative charges to this side. So which basically means that negative charge and neutral, and a neutral one, this is negative, this is neutral, they will attract lor. Basically means like that lah. So negative and neutral will attract, but if it's negative and negative, it will repel. If negative and negative, then it will repel from each other lor. This one will go towards each other lor. This one will also go towards each other. So you have to remember, unlike charges attract, like charges repel. Then if it is like a negative and a neutral one, then you a negative charge ball and a neutral ball, when they are brought close to each other, they will attract also lah. One more thing is that you have to know that if this ball and this ball touches, a negative ball and a positive ball touches, your electrons will transfer to the positive ball. If you touch something, then the electrons will be able to transfer lah. So electrons transfer upon touch lah. That's why when you use the electroscope, you do not touch, but you move it closer. Okay, so the next thing you have to know is electric charge. Its symbol is coulomb. So coulomb is an SI unit. This is an SI unit. Okay, this is an SI unit. Now formula you need to know is this Q equals to NE. Q equals to NE. So this is sum of charge. This is number of charged particles. And this one would be charge of one particle. So here's a word example. So find the charge of 10 to the power of 19 electrons. They give you the number of charged particles. So one more thing you need to know is that the charge of one particle, this E, is a constant. It's a constant value with the value of negative 1.6 times 10 to the power of negative 19 C. Okay, this is the value lah, this is the constant lah. But you don't have to remember this, I don't have to memorize all of this. But if they ask, they will give it to you lah. So yeah, but I don't really see it asked much in the IG questions lah. So how do you find the charge of 2.5 times 10 to the power of 19 electrons? So they give you a number of charged particles. This is a constant, which is negative 1.6 times 10 to the power of 19, negative 19 coulombs. So now they need to find the sum of charge. So you use the formula Q equals to NE. Every time you do a physics question, write down the formula, so that even if you get anything wrong, then you can still get a mark lah. So Q equals NE. So Q equals to 2.5 times 10 to the power of 19 times negative 1.6 times 10 to the power of negative 19 coulomb. So you get an answer of negative 4 coulombs. Okay. So the next thing you have to know is what is an electric field. Okay, an electric field is defined as a region where an electric charged particle experiences and electric force. Okay, one more thing is that if you notice, right, the definition for gravitational field is a region where an object experiences a gravitational force. So the same thing applies for electric field, a region where an electric charged particle experiences an electric force. Electric field means the direction of positive charge. Remember, direction of positive charge. So when your electric field is going this way, means your positive charges are going this way. Okay, remember, there are questions that ask you where is the current heading, or where is the electrons. So you have to know, like, electric field means the direction of positive charge. There's a lot of diagrams about electric field. So the first one was the straight line one. Now there's this one, which is like that. Remember, positive goes outwards, negative goes inwards. Just memorize this lah. Negative goes inwards, positive goes outwards. So when that happens, when you have a positive and a negative, your positive one will go outwards, right? So when it goes outwards, it will connect with a negative. Your negative goes inwards. So yeah, like that lor. Okay, outwards, inwards. The next thing you have to know is the strength. Strength of electric field. So this is two electric fields. So two electric fields. This would be strong, and this will be weak. The further the distance, the weaker the electric field. The closer the distance between the electric field, the stronger it is. Just like the magnetic field. Okay. So the same thing goes for this. This is a weak one, and let's say you have like that. You have so many coming out. Yeah, this would be a strong electric field. This is positive, yeah. Remember, positive goes out, negative goes in. So yeah, this would be stronger and this would be weaker. Okay, the next thing is, there's another term called outside an electric field. So this term is not really asked much, but you have to know lah. Outside an electric field just basically means that a region is the same definition of the region where an electric charge particle does not experience an electric force. It's just that simple. Does not. Just add does not. Okay, so this is done. So the next thing you have to know is the splitting of the reason behind the splitting of candle. So there's two candles. There's two bars. One is positive, one is negative. Here I have a candle. Okay, so if you put a candle in between two one negatively charged bar and one positively charged bar, what you will see is that for a negative charged bar, your flame would be like, your candle, the flame of your candle will split. I think you have done this experiment before. So what's the theory behind this is that this because this is negative, it will attract the positive charges inside the flame. So this is positive, it will attract the negative charges. So what you have learned in chemistry, your previous science, is that the positive charge means protons, right? And your negative charge means your electrons. So protons are bigger than electrons. So as a result, the positively charged part would be bigger, because it's bigger than electron. This is big, this is small. So yeah. Next thing you have to know is current. So the formula for current is I equals to Q over T. So what you have learned just now is that Q is the sum of charge, right? Sum of charge. So sum of charge, what's the unit? The unit will be C, because it's sum of charge. So unit C. Time, this time, SI unit will be seconds. So as you see, C over S, so your I unit will be C per S. And also current is ampere, so C per S or ampere. So it's charge per second or ampere. So that gives you a definition. So this is a definition, which is charge flow per second. Charge flow per second. So in an exam, if you want to answer your questions, just write charge flow per second could also be said as the rate of flow of charge. Flow of charge. If you want to add something more, through a given cross section of a conductor. Okay, so the next thing you have to know is that direction of current. So direction of current, this is simple. So direction of current is the flow of positive charge. So it's positive to negative. What they call this is the conventional current flow. So conventional current flow means the direction of current. No? What happens is that flow of positive charge, right? So actually your positive charges doesn't flow. As you have learned in chemistry, is that it's all the electrons that move and not the protons that move, right? So if your electrons move, then where would your positive charge come from? So the idea behind this is this very simple thing, is that here you have electrons moving in one direction. So when your electrons are moving from negative terminal to your positive terminal, what will happen is that when it moves, let's say, okay, this is the previous negative charge, it moves, it will go here, right? So then this one will also move and it will form a hole. So this one, yeah, this one is like jump to here, this one jumps to here. So when it forms a hole, this one would be the so-called positive. This is called a hole. So this is what they call the positive, so-called positive lah, but it's actually just a hole and nothing inside lah. So this hole, because this one will jump here ma, so this hole would seem like it will be jumping backwards. So that's why it will be, so this whole thing would be your, this hole would be your flow of current. So now we'll be attempting a question here. So we've got current equals 0.5 ampere, time equals to 30 seconds, and find the number of electrons. So what we'll do is we'll just write down the formula, I equals to Q over T. So now we've got current, so we write down current, 0.5. Q, we don't have Q, so we just write. Q is the sum of charge, right? So time, we've got 30 seconds. So now we can find Q. Q equals to 30 times 0.5 equals to 15. So Q is the sum of charge. So 15C, remember to write your unit. So number of charge, the sum of charge doesn't mean the number of electrons. As you have known the formula that we have learned earlier, Q equals to NE. Right? Q equals to NE. This is the number of charged particle. And this is a constant. So now we've got your 15 as the sum of charge equals to number of charged particle, which is your unknown, times your constant, which is E. E as a constant is negative 1.6 times 10 to the power of negative 19. So which brings us to an answer of 9.375 times 10 to the power of 19. Okay, so next thing we have to learn is the arrangement of voltmeter. So the arrangement of voltmeter is like that. Okay, so here we have a circuit with two resistors, resistor 1 and resistor 2. So how do we fit in the voltmeter? So we will have to fit it like that. Okay, we have to fit it parallel to the circuit. Why parallel? It's because your voltmeter is not a conductor. So when it's not a conductor, it will not let any current pass through. So the next thing is arrangement of ammeter. So arrangement of ammeter is simple. You have to be in series because your ammeter is it allows charges to pass through. So you just arrange it in series. It would not affect anything. So Ohm's law states that the current is directly proportional to the potential difference when all physical conditions are constant. So physical conditions, for example, are length and temperature. So as you know, when the temperature increases, your resistance will increase. Ohm's law. So Ohm's law states that the current is directly proportional to the potential difference when all physical conditions are constant. So physical conditions, for example, is length, temperature. So what you have to know for this is that for every single law, there will be a limitation. So for this, the limitation is when all physical conditions are constant. So let's say for Hooke's law states that the load is directly proportional to extension when within the elastic limit. So there's a limitation within the elastic limit. So for this, the limitation will be when all physical conditions are constant. So those conductors that obey Ohm's law are called ohmic conductors. Okay, so as I've stated, directly proportional. So this would be the graph, voltage against current. So as you can see, it is directly proportional. So whenever you see graphs like directly proportional, means that it's a straight line starting from the origin. Okay, straight line starting from the origin means directly proportional. So here, the gradient will be the resistance. The gradient will be the resistance because V equals IR. So V equals IR, Y equals mx plus C. Your C will be 0 because this is y-intercept. So your R would be your M and I would be your X. So this would be your graph. So whenever if they ask you to find the resistance through this graph that they have given you, so you just find a gradient. Okay, so for graph of I against V, the graph would be something like this. So what you have to know is that if it is a graph of I against V, the gradient will be equals to 1 over R.
Why do I say that the gradient of I against V is 1 over R when the graph is I against V? So V equals to IR. This is your Y equals to mx plus C. So if I make I as your Y, so you get I equals to V over R, which is equals to 1 over R. Which means that your gradient will be 1 over R. And your V will be your x-axis. Y equals mx plus C.
So next thing we have to learn is the factors affecting resistance. So one of the factor is length. So if you imagine it, length, if your charge has to cover a longer distance, so it means that it will face more resistance along the way. So if you think like that, means that when your length increases, your resistance increases. Okay, so cross-sectional area. So imagine yourself in a small hole. This is the cross-sectional area. So if you pass through a small hole, would you face more resistance, or more resistance compared to if you pass through a bigger hole? So if you think of it that way, so cross-sectional area would when you increase your cross-sectional area, your resistance will decrease because you have a larger space to walk through. Imagine you have the charge, so you have a larger space to walk through. So temperature. So how temperature affects resistance is because of let's say when your temperature increases, your resistance would increase too. Why? Because when electrons gain temperature would cause your electrons to gain kinetic energy. So if your electrons have higher kinetic energy, it will move faster. And thus, since it's moving faster, it will just collide into each other. So they will just start colliding with each other. So this collision causes resistance. You get what I mean? So if they collide with each other, there's resistance. Let's say you collide with your in a crowded place, and if everyone moves faster, the resistance will definitely be higher. So type of material. So this one, it's pointing towards the resistivity of the material. We will learn about this in a bit. So as I've said, resistivity. Resistivity is represented by the symbol rho here, this symbol rho here. So the formula will be rho equals to RA over L. But if you want to remember it in a different way, then you can remember it as resistance equals to rho L over A. So R means resistance, A means the area of cross-sectional area of your conductor, and L means the length of the wire. Okay, so resistivity is like how much the material resists the movement of charge. Okay, so you have to understand the concept behind same material means like they have the same resistivity. Let's say you have a copper and a copper, they will have the same resistivity. Whenever you have the same resistivity, you can use this formula R1, because this is the resistivity. If you have the same resistivity, means that your rho equals to rho. So that means you can use it in this way to find either one of the unknowns. Let's say I will give you A1, L1, and I will give you the resistivity will be 2. So you will be able to find your R1 by just swapping by just doing simple math, right? So but please remember, whenever you use all this formula in physics that they give you, remember to change everything to SI unit. Okay, and one more thing, this formula will not be given to you in the exam, so please memorize it. R equals to rho L over A. Since you have memorized, if you choose to memorize R, then you can just shift around to get your resistivity, which is your rho. But if you want to memorize in this, then you can still change it yourself. So here's an example question. Here I give you 2 bars of the same material, means that you can apply the formula R1A1 over L equals to R2A R2A2 over L2. So I'll stick to the formula R equals to rho L over A, and I'll change it myself because I've memorized it this way. So here I give you 5 ohm as the resistance, area 2 cm square, 10 cm, 5 cm square, 15 cm, and I have to find the resistance. So what I have to do first is that I have to convert all this units into the SI unit. Remember, it's very important. If you don't convert it to the SI unit, then you may or may not get the wrong answer. Even if you get the correct answer, it is still the wrong way of doing it. So here we go. So I'll get RA over L, R1A1L, okay, equals to R2A2 over L2. After we've got this, we just sub in everything we have. So let's say I'll treat my R1 as this and R2 as this. So R1 is 5 times by A is, it's 2 cm squared, so convert it. So how do you convert 2 cm squared? Just 2 divided by 100 divided by 100, yeah, then you get 2 times 10 to the power negative 4 and over 10 cm, so it will be 1 to 0.1 equals to R2 is my unknown times by my 5 cm, which is 5 times 10 to the power of negative 4 over 0.15. So after pressing my calculator, I'll get 3 ohm. So that's it. Simple, right? Okay, moving on. we'll talk about the concept behind what's happening if you double the length, the calculation behind it. So exam questions, they do ask you about what if I double the length, what will happen to the resistance. It's very common, so you have to know it. If you don't want it, if you don't understand how it comes out, then just memorize it. But I would not recommend you to memorize it if you can like work it out yourself this way. So let's see if your length doubles, your resistance doubles. Why? Because look at this. RLOA, this is your resistance. Resistance formula is R equals to rho L over A. So when my length doubles, 2L, I'll put 2L here. So after that, I'll just move my 2 out, 2 times rho L over A. So rho L over A is my resistance. So if I double my length, it will be twice the resistance. So meaning my resistance would double. Same goes for area. So we can use the same method. So area doubles. So when my area doubles, I'll just put 2A. 2A means that it's divided by 2. So 1 over 2 rho LOA. So I'll just put a bracket here. Yeah. So rho LOA is R. So half the R. So R halves when you double your area. So that's how you calculate it. So now comes the tricky one, which is doubling the R or your radius or your diameter. So this is quite tricky. So follow me if you can. So rho L over A, your A is pi r squared because it's circle, right? Your cylinder is a circle, so pi r squared. So R equals to rho L over pi times, because you double. Let's say you double your radius. So you double your radius, pi times 2r squared. So when you do that, you get rho L over 4 pi r squared. You get pi 4r squared. So here you get rho L over 4 pi r squared. So that would bring you to this, which is a quarter of the resistance. So if you double your radius or your diameter, you'll get your resistance will quarter. So electromotive force is what we'll be learning next. So the next thing we'll be learning is electromotive force. It has the same symbol as potential difference, which is voltage. So does that mean it's the same with potential difference? I would say no, because there's definitely some similarities and some difference between them. So the definition for electromotive force is the work done to move one coulomb of charge across a complete circuit. So what does a complete circuit mean? A complete circuit would mean going from the positive terminal to the negative terminal. It means that you move one full cycle through your circuit. Okay, so when compared to potential difference has the definition of work done to move one coulomb of charge across one point to another. So yeah, that's the main difference behind it. One is one point to another, this point and this point, but the other one is through the complete circuit. Okay, so the next thing you will have to know is what is internal resistance. So internal resistance is the resistance that is present inside the battery source. I would say that whenever there is any movement in this world, like really, if you move something, there will definitely be resistance, friction or whatever. There will definitely be resistance. So same goes with battery. When it generates electricity, when it generates the voltage, the potential difference, it would have resistance. So inside the battery itself, there would be resistance. So let's say if the supplier gives you a 3 volt battery, there will definitely be resistance. So it might not come out as a 3 volt battery. Yeah. So the 3 volt will be the EMF, which was calculated like the maximum capacity of it. It will be 3 volt, but in actuality you won't get 3 volt because there will definitely be internal resistance inside. Okay, so the next thing would be load resistance. Load resistance is the effective resistance against a moving charge outside of the electric source. So this one is outside of the electric source. Means that let's say you put a resistor, that will be the load resistor. If you put a lamp, it will still be a load resistor too. Anything that you put inside a circuit that is not related to the electric source, which is the battery or your generator, is counted as a load resistor. there's two types of resistance that you have to know. One is internal resistance, one is load resistance. Internal resistance is the resistance inside the battery source, and while load resistance is the resistance outside of your electric source. So the next thing we'll look into is this. Before we start, I would like to explain more about internal resistance. So here it is. So inside a battery, there will be electrode and electrolyte. I bet that you have learned about this in your chemistry. If you have not, then try to understand this. So, or look up into it, or you can ask me if you don't understand lah. So, you will definitely undergo electrolysis. Not really electrolysis, but inside a voltaic cell, it will produce electricity. So during this process of producing the electricity in a voltaic cell, there would definitely be resistance, as I've said. So whatever charge that comes out won't be 100%. So the resistance that causes the charge to be released to not be 100% is called the internal resistance. Then the other term that you have to know is the terminal potential difference that I will be using here. So it's nothing difficult, it's just with a terminal. So it means that the potential difference across the two terminals, like positive and a negative. So like positive and negative, this will be just the terminal. Positive terminal and negative terminal, it's just simple. Okay, so now here we have two examples here. Now my EMF, I've got two EMF with the same voltage. So one is without internal resistance and one is with internal resistance, but this is just assuming that it has no internal resistance. I doubt that there will be anything that would have no internal resistance. So without internal resistance, the EMF produced by the battery itself would equals to the terminal potential difference, which is the voltage of these two terminals. The voltage across these two terminals. So if it is with internal resistance, the terminal potential difference would be lower than the EMF. So technically speaking, the EMF is like the maximum capacity that a battery can supply, but the terminal potential difference is the actual voltage or potential difference you would get in real life. Next thing we have to know is that EMF, here's a formula. So E equals to V plus IR. This little R here means the internal resistance, while the bigger R means the load. Okay. As I've said earlier, EMF is like the maximum capacity that you will ever get, and that this terminal potential difference is like the actual thing that you get. So now we have formula E equals to V plus IR. So this E would definitely be the electromotive force, and this V is the V equals IR you usually use for your formula. So the V here would be a terminal potential difference plus your internal potential difference. So technically speaking, your EMF would mean the potential difference of both the outside and inside of the battery. So when you convert V into IR, because V equals to IR, so technically you can see the relation between it. IR plus IR, which can be simplified into I times R plus R, because the current would definitely be the same across your inside your battery and outside your battery. Your current will be the same. Okay, so here's an example. A cell has internal resistance of 0.5 ohm and potential difference across cell is 4 volts. So, and when a 2 ampere current flows through it, find the EMF. So how do we do it? So very quickly, we'll just write down the information that we got here. So potential difference across cell, which means this is the terminal potential difference, which means it is the load resistance. So it's the V equals to 4 volt. And the current equals to 2A. Okay, so here I've written a formula with E equals to V plus IR. So if you want to try it out yourself, you can just pause the video and try it out. So E equals to V plus IR. So here we need to find the EMF. So now I've got a V4 plus my 2 times my internal resistance, which is your 0.5. Here I'll get my answer as 5 volt. So now moving on to the graph. So this is the graph of your electromotive force, E equals to V plus IR. So if we move it to make V as your y-axis and I as your x-axis, we will get this V equals to negative Ri plus E. So here we write this y equals to mx plus c. So m will be your negative R. So it means that your gradient will be going down. So C will be your E, and I is your x-axis, while y will be your voltage. Okay, so when I equals to 0, means that there is no current at all, means that your EMF will be at its maximum, means that no charge is flowing. When there's no charge flowing, your EMF will be at its maximum because there will be no internal resistance. So that's it. So now that you know that the gradient is negative R, you can draw your graph negative with a negative gradient slope. So the next thing we will be touching on would be the resistance. So the unit for resistance is ohm. And for series, the resistance, the total resistance would be the total of all the resistor, all the load resistor present, which is R1 plus R2 plus R3 if there is like 3 resistors lah. While parallel, you will start with 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3, and if you turn it into a power sign and you move it over here, then you get 1 over R1 plus 1 over R2 plus 1 over R3 equals to power negative 1. So this would be a formula for parallel resistance. So here's a few examples. For examples, they are all very simple examples, so we'll just run through it very quickly. So for the total resistance for this is series circuit, so it's 2 plus 3 plus 6 equals to 11 ohm. Remember to write the units. So R total for this one, 333. So you get your 1 over 3 plus 1 over 3 plus 1 over 3 power negative 1, and you get 1. Because it's 1 power negative 1, so it's 1. So here we have another one, which is a parallel circuit. A parallel circuit here, so we'll do it this way. So it's 3 plus 3 equals 6, plus 1 over 6, so I'll get so for this 1 over 2, 1 over 2, so I'll get 1 over 2 plus 1 over 2 power negative 1 plus 3, so it's equals to 4 ohm. Okay, the next thing we will have to do is you would sometimes maybe they would, I mean, this is the proof that series circuit has more effective resistance. So we just prove it with the same type of resistor lah. So we've got 3 resistors here and 3 resistors here. So if we put it in series circuit, it will be just 3 plus 3 plus 3 equals to 9 ohms. But for this, 3 plus 3 plus 3, but it's going to be 1 over 3 plus 1 over 3 plus 1 over 3 power negative 1 equals to 1. Yeah, so here's an example. So we have to find this R resistance, resistance of this R resistor, and we are given the effective resistance of the whole circuit is 4 ohm. So we just write down 4 equals to 1 over 2 plus R plus 1 over 3 power negative 1. This is the formula, right? And plus 2. So here we'll get 2 equals to next thing we will be learning is the current in series circuit. So the current in series circuit is the same throughout all resistors. Current is the same throughout all resistors. So while current in parallel, when it branches from the series to parallel, it will divide itself accordingly. So I1 plus I2 equals to the on initial I. So if this is 2, this is 4, then the initial I will be 6. Okay, so we'll move on to an example very quickly. So here we've got EMF 3 volt as the power supply, and I1, I2 we are asked to find I1, I2 respectively. So V equals to IR. Remember to write the formula. So that equals to R. 3 equals to I times this I1 times 3, which means I1 equals to 1 ampere. While for this I2, V equals to I2R. So equals to 3 equals to I2 times by 6. So I2 equals to 0.5 ampere. So remember, for electricity, we remember to write everything in decimal. Do not write it in fraction because they might deduct your mark for doing so. So if we got this, we can get the total as 1.5. So there's another way of getting the total current. So the other way would be you just find the resistance of this. It will be 103 plus 106 power negative 1. This one equals 2. So the resistance equals 2. V equals to so V equals to 3, right? 3 equals to I times 2. So I equals to 1.5 ampere. So that's how you get it. So it will not be the same if So the next thing we'll be doing is potential difference. Potential difference, I'll repeat the definition, is the work done to move one column of charge across from a point to another point. So for series circuit, all your resistors added up, all your potential difference of your resistors added up would be the total potential difference, also called the terminal potential difference lah. Okay, so for parallel, it will be the same. The terminal potential difference, and all the other resistors would receive the same amount of potential difference. We'll just jump to an example very quickly. So now our question states that the circuit has an EMF of 12 volt, and they are asking us to find the potential difference at R1 and R2 respectively. So respectively, so here we go. So now we will have to write the formula down first. IR. So we don't have the current. So let's look for the current first. So 12 equals to I times 6, 2 plus 4, so I equals to 2. Since we know that the current is 2 ampere, we just start off with IR1. So this one V equals to 2 times 2. So my voltage across the R1 will be 4. So if you notice, this 2 added up, 4 plus 8 equals to 12, which is equals to the EMF here. So next thing we'll be learning would be the LDR and thermistor. There are some questions asking about how fire alarms work and stuff. So LDR is a short form of light dependent resistor. Thermistor is a resistor that is affected by heat lah. So yeah. So for light dependent resistor, remember, when light increases, your resistance decreases. Same goes for thermistor. Temperature increases, resistance decreases. It's kind of like the opposite of what we just learned. Since we've said that temperature increase, your resistance will increase because of the collision between your electrons, right? But for thermistor, it will be different. For thermistor and your LDR, it's kind of different because when your light intensity increases and your heat increases, it kind of melts the components inside. So if I'm not wrong, it's called silicon. So when it melts, it allows the charges to flow easier. So when your charges flow easier, means that there's less resistance in your conductor. There are quite a few daily usage of these two resistors. So one is fire alarm and one is street lights. We'll get to that later as we discuss more about it. Okay. So here we have potential divider. So potential divider, it's just a pretty simple concept of dividing the potential difference. So the concept is simple, but it's kind of like one of the hardest part of this electricity chapter that most people wouldn't understand at first glance. So what you have to know is when there's more resistance, you will need more work done to to face the resistance. So which means that work done higher means that your potential difference will be higher. So it's just that simple. Let's say 8 ohm. So 8 ohm will have a higher potential difference. You can just see by, you don't have to calculate, and you know that 8 ohm will have the higher potential difference and 4 ohm will have the lower one. So here's a formula for it, but you don't really have to use the formula. But now we'll be using the formula first. So V output is our output here. We are looking for our V output. So V output over our V input is 24 equals to R1 over R1 plus R2. So my R1 would be my the output that I'm trying to find. So it's 8. So 8 over 8 plus 4 equals to 12. So since I've gotten this, I know this is a series circuit. So 24 equals to 16 plus by my V2. We'll name it V2. So 24 minus 16, I'll get 8. Whoa, sorry, I'm pretty lazy to calculate. That's it. But if you want to go about the more like the common sense way, there is a way to do it. So since I've given you the 24 ohm as your, so I'll just use V equals to IR as the main formula. It's just using V equals IR. So 24 equals to I times by my 12. Your total resistance is 12, so I equals to 2A. So when I equals to 2 ampere, you can start calculating. So V equals to 2 times 8, you get 16. While the other one would be 2 times 4, you get 8. So add up, you still get 24. So how this formula works is like, this is like a fraction of the potential difference it's taking. So R1, let's say 4 over 12, means that it's taking 4 parts of the 12 parts. 4 potential difference as, like, let's treat potential difference as a character. So we're taking 4 characters over the 12 characters. Yeah. So now if we've got a fraction, we just times it by the total and we'll get the output that we want. So that's all. Here we have another question. E equals to 3V, R equals to 1 ohm, R equals to 5 ohm. Find reading of wattmeter across the resistor. So this is the E equals to V plus IR.